Hello, Ashwin. Ashwin, please switch on your camera.
Yes, ma'am.
Sanjay, what happened? You went early yesterday?
Ma'am, actually I had a parent teachers meeting.
Oh, you had a parent teacher.
That's all.
Siraf chai. Ashwin, hello.
Yes, ma'am.
Can you please switch on your camera for a minute at least? The moment, yeah, Ashwin. Now tell me, Ashwin, yesterday you were not there in the meeting. What happened? I was calling your name again and again. You never replied. What happened?
Ma'am, I was not able to mute, ma'am.
You were not able to unmute.
Yes, ma'am.
So there is an option for chat, you know. So if you are there and you are not able to answer, you can at least message me on chat, isn't it?
Ma'am.
If there is something you don't understand, Ashwin, then I need to know that, isn't it?
Yes, ma'am.
I'm here to help. That's all. And you are all young people. If you don't know something, you can find out. Sanjay can help you, Madhavan can help you. If there is something you don't know how to do, please try to understand, or otherwise there is an option for chat. Send a message on chat saying, ma'am, I am not able to unmute. I can unmute you, actually. I can also unmute you, right? So you have to let me know. Okay, Ashwin?
Okay, ma'am.
So were you there throughout the meeting, or you, because towards the end I didn't even see you. You were not there only.
Ma'am, I was not there at last 10 minutes, ma'am.
What happened? See, I don't want to question all of you because you are all responsible children. See, below 10 standard, we can scold you, we can tell you, but now you are here, it is your own responsibility, right? Learning or not learning, it is your responsibility. So all of you, this is my request to all of you, do attend the class with full sincerity. If there is something which you don't understand, you think I am going very fast, if you are not able to understand anything, you tell me, I can explain in another way, right? So there has to be some communication. Understood or not?
Yes, ma'am.
Yeah. So in your school, what has been taught in your school, Ashwin? What are you learning in school?
They completed haloalkenes and arenes, ma'am.
Okay, they completed that. Very good. So now you also, because you have not attended my class on haloalkanes and haloarenes, did you see the recording?
Yes, ma'am.
Okay, so go through the recording, prepare well for the test, write the assignment, send me the assignment so that I can correct and tell you what is a mistake, right? Who is the host? Is there somebody who is the host here? Sanjay, are you the host? Or Vaishnavi, are you the host?
No, ma'am.
Okay, let me find out. Hello, please enable the screen sharing. Yeah. Madhavan, how's your preparation going on? Did you go see the remaining videos now?
Oh, yes, ma'am.
Okay, so please go through all the assignments so that it will help you to do the test better, right?
Okay.
Do you have only chemistry test this weekend or it is also
Maths
the other?
also.
Oh, maths also. Okay.
Ma'am?
Yeah.
Ma'am, in the book back exercise, I have a few doubts, ma'am.
Yeah. Tell me.
Ma'am, the
It
first
is
one is
in which chapter? In which chapter is it?
ma'am, haloalkanes and halogens.
Okay. Tell me.
Yes, ma'am. Ma'am, the 11th question, first one, ma'am, ethanol to butane.
Okay, I will just take another slide and I will show you. Tell me, butanol to?
Ma'am, ethanol to butane.
Ethanol to but1-ine. So that day when we were doing all the questions from your textbook, this particular one I told you don't do it now because it involves the we can try anyway, but I will tell you what the problem is. So ethanol to but1-ine, first you should see ethanol has 2 carbon atoms and but1-ine has how many carbon atoms? It has 4 carbon atoms. So the first thing I need to do is I need to change 2 carbon atoms into 4. Okay, so I need to double the number of carbon atoms. What is the method to double the number of carbon atoms?
Ma'am, 2
Food
sodium and
and alkyl halide. So first what will I do? C2H5OH plus PCl5, right? So what will I get? C2H5Cl, right? And then C2H5Cl, let me write it as CH2CH3. So CH3CH2Cl plus 2Na plus Cl CH2CH3, right? So I will get what? Butane.
yes, ma'am.
Did you understand how I got butane?
Yes,
and NaCl is a byproduct, so I don't bother about it. Okay, so this is a byproduct. Even if you don't write it, it's okay. You got butane. Now from butane, I need to do chlorination. Okay, so when I do chlorination, the secondary hydrogen will be substituted. So there will be one. First, you can put a Cl here. Chlorination of alkanes to get haloalkanes. So you will get CH2, CHCl, and here CH3. It's a long one. So now what will I do? I will put here, I want to make it an alkene. So what will I do? Alcoholic KOH. So it will become CH3, CH2, no, CH, double bond CH, CH3. Right? Alcoholic KOH, you remember this reaction?
Yes, ma'am.
And then you do add again chlorine. Now it is addition on the double bond. So what will I get? CH3, CHCl, and again CHCl and CH3, right? And now if I do alcoholic KOH again, 2 times, I will get 2-butane. No, you need to get 1-butane. Okay, that is a little problem. So how to get 1-butane? I need to have.
Ma'am, after getting butane, can we use Markovnikov rule and change it to but1-ene, and then again by alcoholic KOH can we bring to but1-ene?
No, but1-ene. See, by adding HCl here, you are saying you add HCl here?
No, ma'am. First you wrote, ma'am, after adding alcoholic KOH in the last step, we will said like we will get but2-ine.
First, yes.
Yes, ma'am. So after getting but2-ine, can we again use Markovnikov rule? Oh,
No, you can't do that. You can't do that. Let me tell you, there is another way of doing it. You need to first convert it into ethine. But1-ine. Propine. First, we need to make it into propine. I'll have to do it in another way. I didn't notice that it is but1-ine. In that day when we were doing, we didn't touch upon this. I'm surprised. Anyway, so first we'll have to make it but1-ine. First we will have to make it add NaCN, right? So we will get CH3, CH2, CN, right? Now this. but1-ine, the butene. First, I should make but1-ene, then butene. Anyway, right now I am not able to think of an easy method of doing it. There are methods which you can do after doing this one, aldehydes and ketones, but that method I don't want to go into right now. So give me some time. I don't know how I will tell you before the exam. I will write on a piece of paper. I will send it to you through Mr. Bhaskar. You will get it. Okay, so I will give you a solution. So yesterday, children, we were.
Ma'am. Ma'am,
anything else? Yeah, yes, tell me. Yeah.
How should we write the mechanism for like the 15th question, ma'am?
Can you tell me the question?
Yes, ma'am. Ma'am, write the mechanism of the following reaction: NBuBr.
Okay.
Plus KCN.
BuBr plus KCN.
Gives NBuCN.
NBuCN. Okay.
Yes, ma'am.
Now here to write the
given like ethanol and H2O.
Yeah, ethanolic KOH, ethanol and H2O. Okay. Now here, Bu means NBu means butane, butyl, N-butyl. NBu sometimes they write for butyl. Butyl means 4 carbon atoms. So CH3, CH2, 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 they are in a chain, and Br, right? Now this is what type of alkyl halide? This is a primary alkyl halide, primary. Right? And this with KCN will give you N-butyl cyanide. So what will you get? CH3, CH2, 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 and CN, right? Plus KBr. Now, if it is a primary alkyl halide, right? What type of mechanism will it show? Tell me. It will show SN2 mechanism. Right? I told you SN1 and SN2. So SN1 is shown by tertiary and primary will show SN2 mechanism. So this is going to show SN2 mechanism. So how will you write a SN2 mechanism? To write a SN2 mechanism, you have to write the attack of, first you show this cyanide. It is ionic compound, so cyanide will ionize to give K plus Cn minus. Now the second step of this is how the cyanide is produced. Then the reaction you show like this. You can write this Bu. This is BuBr. Let us write it as Bu itself. So Bu and slowly break this bond, Br. Okay, so this is delta negative and this is delta positive. And Cn is approaching from here. This is delta negative. All right. And this will break and this will form. So you just have to write BrCn, BuCn, BuCn plus Br minus. That's all. That is the way you will write the mechanism.
Yes, ma'am.
Anything else?
No, ma'am.
Anybody else has any doubt in alkyl halides? Children, anybody else has any doubt? Okay. So in the last class, children, we were doing elevation. We completed lowering lowering of vapor pressure, and we just started elevation of boiling point. And I showed you how by adding a solute in a solvent, the boiling point of the solute will be increased. The boiling point of the solution will be increased. So since the boiling point of the solution is increased, let me see who all have come. Ashwin, Vaishnavi, Sanjay, Hariraghav. Okay. Okay. So, so the rule here I gave you in the last class, the rule that I gave you was that the elevation in boiling point. So initially, let the boiling point be, boiling point was T2 and final was T1. So change in boiling point is T1 minus T2. So delta T is equal to change in boiling point T1 minus T2 minus T1. So the boiling point T2 you can see is more than T1. So delta TB, B stands for boiling. So delta TB is proportional to, so I will show you this part again. So here the rule is that delta TB is proportional to M. What is delta TB? Delta TB is elevation in boiling point or increase in boiling point. In boiling point by adding a solute. Okay, increase in boiling point of the solution by adding a solute. And what is M? M is molality of the solution. That means concentration of the solution expressed in terms of molality. Now to remove this sign of equilibrium of this proportionality, we can say delta TB is equal to KB into M, where KB is known as the ebullioscopic constant. Ebullioscopic constant. And this constant has a particular value for all the solvents. Different solvents have different values, and ebullioscopic constant will always be given to you in the question. Now, the other thing that you have to understand is sometimes they ask you the definition of ebullioscopic constant. So what is ebullioscopic constant? So if for a particular solution, you are looking at a solution, if M, molality of the solution is equal to 1, right? Then what will be delta TB equal to? Delta TB is equal to KB. So from here, you can write the definition of ebullioscopic constant. So what is the ebullioscopic constant? It is it is equal to, ebullioscopic constant is equal to the elevation in boiling point, elevation in boiling point of a solution which has the concentration 1 molar. Okay, if the which has a concentration 1 mole per kilogram. If the concentration of the solution is 1 mole per kilogram, then the elevation in boiling point is equal to the ebullioscopic constant. Elevation in boiling point is equal to the ebullioscopic constant. Now we will do a little more, continue this. So I told you what? Delta TB is equal to KB into M, right? I can also say KB is equal to delta TB divided by M. All right. What is the unit of temperature? Kelvin, right? If I am trying to find the unit of KB, what is the unit of KB? Kelvin divided by M, that is moles per kilogram. So what is the unit of KB I can write? It is Kelvin kilogram per mole. That is the unit of ebullioscopic constant. So always remember, it is Kelvin kilograms per mole. Now this formula delta TB, I will elaborate it a little more. KB into M. What is molality? Molality, somebody tell me, what is the formula for molality? M is equal to what?
Moles of solute, number of moles of solute divided by mass of solvent in kilograms.
Moles of solute divided by mass of solvent in kilogram. Right? So I can substitute this value here. So I can write KB into moles of solute divided by mass of solvent in kilograms, right? Now, what is moles of solute? N. What is moles of solute? It is, somebody else tell me now. What is moles of solute? Hari Raga, what is moles of solute?
Ma'am, it's by 1,000, ma'am.
No, moles of solute. What is moles of solute? If I want to
it's given mass by molar mass.
Huh?
I'm given mass by molar mass.
Yeah, mass divided by molar mass. Okay, and mass of, now here we are talking of solute. So I can say number of moles is equal to mass of solute. Let me take it as WB. I told you everything about the solute we'll consider as B. And molar mass of solute, let me take it as MB. Okay, so I'll put these values here. So what will delta TB become equal to? It will become equal to KB into WB upon MB into mass of solvent. Mass of solvent, I will take it in as WA. But WA should be in kilograms. Normally in the solution, in the question, the mass of the solvent is given in grams. So to convert grams, what will I do? Multiply this by 1,000. Okay, so this becomes my formula for elevation in boiling point. Now, out of these values, there are 1, 2, 3, 4, 5 values here. Any one will be unknown. Any one will be unknown, and the unknown value you have to calculate by doing the question. So that is a type of numerical. So the first type of numericals we did with lowering of vapor pressure. Now we are doing the numericals with this. Now, depending on what is given in your question, you can use this formula, or you can use this one, or you can use this one. Remember that what is important to remember, that in this formula, mass of solvent should be in grams. mass of solvent should be in grams, because if the mass of solvent is in kilograms, then you should not use the 1000. Okay, so let us do 1 or 2 questions so that we understand. Now, this is the first question. Okay. Now, I hope you can see it better now. Okay. What is the molecular mass of an organic compound? If 16 grams of the compound is dissolved in 225 grams of carbon tetrachloride, raises the boiling point to 85 degrees Celsius. Boiling point of carbon tetrachloride means pure carbon tetrachloride is 76.72 degrees Celsius, and ebullioscopic constant for carbon tetrachloride is 5.03 per degree per Kelvin per mole. Here they have given it in degrees centigrade. It does not matter. You can write the answer also. You can write in degrees centigrade. So what is our data given? Data given. So what is it that we know? The mass of the organic compound. So the organic compound is WB is 16 grams, right? Then compound is dissolved in 225 grams of carbon tetrachloride. So WA is equal to 225 grams, 225.0 grams. Then what is the boiling point? T1. We have to find out delta T. So T1 is given to you 76.72 degrees Celsius. T2 is given here. What is the new temperature? Boiling point, 85.36 degrees Celsius. And KB is given as 5.03 degree Celsius Kelvin per mole. Okay, so what is our formula? Delta TB is equal to KB into WB into 1000 divided by WA into MB. Okay, and what is it that we don't know? We only don't know MB. All other values are known. 1, 2, 3, and 4 are known to us. So let us first find out delta TB. Delta TB is equal to what? T2 minus T1. So please find out quickly. 85.36 minus 76.72. What will you get? Somebody please keep doing along with me.
Ma'am.
What did you get?
8.64.
8.64. Okay, degrees Celsius. You need not change it into Kelvin because it is a difference. So whether it is degrees Celsius or Kelvin doesn't matter. So now put all the values. What will it be? 8.64 is equal to KB 5.03 into WB. WB is 16 into 1000 divided by 225 into MB we have to find out. So can you find out MB? Let me see who does it first. Sanjay, do it quickly. You have a calculator, Sanjay? Do you have a
1 minute,
calculator?
madam.
Yeah, do it
1
quickly.
minute.
Hmm.
Ma'am, is it 40.7?
40.7. 40.64. Let me see if anyone else gets the same. Are you using a calculator, Vaishnavi?
No, ma'am.
Okay, then your answer is right. It's close to 40 only, the answer.
Ma'am,
Anybody else?
ma'am, 41.3.
41. Yeah, 39. You also can get 41.39. By calculator, you get 41.39. If you do by approximation, around 40. Did all of you understand the method? Sai Kalyan,
Yes, ma'am.
did you find the answer?
I'm doing it, ma'am.
Okay. So what you all do is don't spend time in doing the calculation. Note this, and then you can do the calculation by yourself. I am more interested in knowing whether you can arrive at the correct answer using the correct formula. Okay. Now I am telling you in the exam, most of the time the question is such that you can cancel easily and arrive at the answer because you all are not allowed a calculator. So if you think that lot of time is being, it's taking a lot of time, then what you should do is you should simplify it as far as possible, and then leave it with the correct unit. What is the correct unit here? It is gram per mole. Okay, so if you do that, only half mark you will lose. Even if you don't do the complete calculation, you should leave the answer in gram per mole. Okay, now let us do one more question. Now this is the same type. I just want you all to do it with putting correct values. Okay, so now in the a solution of 10 grams of a non-volatile, non-dissociating compound. Now every time we are saying non-volatile, non-dissociating compound, it is for a reason that you will understand a little later. So it doesn't matter now, it will always be, we want it to be a non-volatile and non-dissociating because we know we don't want any vapor pressure coming out of the solute. That is why they always write like this. So what is WB? It is 10 grams. Then 0.2 kilograms of solvent. So WA is equal to 0.2 kilograms. And benzene boils at, so T2 is 81.2 degrees Celsius, and T1 pure benzene, it is 80.1 degrees Celsius. And ebullioscopic constant, that is Kb, is equal to 2.53 degrees Celsius per m. This m, small m, stands for molal. So sometimes instead of saying kilogram, so they can write molal or m. So what is the, the molar mass of benzene? No, We have to find the molar mass of the compound. So we know 1, 2, 3, 4 things are given. So first find delta T. Delta T is equal to T2 minus T1. So that is equal to 81.2 minus 80.1. So that is equal to how much? 1.1. Now substitute the values. Write the whole equation so that you will remember the equation properly. WB into 1000 divided by WA into MB. So 1.1 is equal to 2.53 into WB is 10 into, now remember here the weight is given in kilograms, right? 0.2 into MB, right? So here we will not take, we will cancel this. Why are we cancelling? Because your mass of the solvent is already in kilograms. I hope you understood what I am saying. So MB is equal to what? It is 2.53 into 10 divided by 0.2 into 1.1. Now somebody find out the answer quickly. This time, let me see who else has come. Hari Raghav is there. Sai Kalyan, Ashwin. Ashwin, can you find the answer? Ashwin,
Yes, ma'am.
Yeah, do it quickly.
Ma'am,
Vaishnavi, don't say the answer. I want somebody else to say. Is there any difficulty, Vaishnavi?
no, ma'am.
Okay, very good. Anyone who will tell me the answer? Vaishnavi, you don't tell me. Somebody else should tell.
Ma'am,
Yeah. Sai Kalyan, tell me.
ma'am, is the answer 115?
Yes, 115 gram per mole. Ashwin, Hari Raghav, did you get it?
Yes, ma'am.
Yes.
Yeah. Now, did you all understand why I canceled 1000 here? Why I didn't take 1000 here? It is because the mass is already given in kilograms. And what did I tell you? I need to use 1000 only if my mass is given in grams. If the mass of the solvent is given in kilograms, then I don't have to use 1000. Because why do I multiply by 1000? Because this mass of solvent, if it is in grams, it has to be converted. So that we do it in the formula itself. Now do the next one. Yeah?
Can we go to the last sum? Ma'am, here the 0.2 kg, if we write it as grams, then we can use the 100,000.
Yes, 0.2 if you write it as grams. So you can convert it in multiply by 1000 and convert it into grams. How will you do? Multiply by 1000. So it will become, what will it become? Huh?
200.
200 grams, right? So I can put here 200 grams. I can do that, right? So if I put here 200 grams, then I can multiply by 1000. Then there is no problem. Understood? Okay, now let us do the next question. Okay, now in this next question, now see how we are doing the next question. Now seawater is about 3.5 by weight dissolved in of dissolved solid, almost all of which is sodium chloride. Calculate the normal boiling point of seawater. We have to calculate the boiling point of seawater. Now, first thing is what do we need? What are we given? Sea water is 3.5 by weight, 3.5% by weight of sodium chloride. So 3.5% weight by weight means what? 3.5 grams of NaCl in 100 grams of solution. Right? We learned it in the beginning. What does weight by weight mean? The percentage, weight by weight percent is mass of the solute divided by the mass of the solution into 100. So when I say 3.5, I mean 3.5 grams of sodium chloride in 100 grams of solution, right? So what is WB? That is 3.5 grams. And what is WA then? WA is the mass of the solvent. How will I find the mass of the solvent? It is 100 minus 3.5. So that will be how much? 90, not 97, 96.5. So mass of the solvent will be 96.5 grams, right? Then MB, you know, okay? MB is the mass of the molar mass of the solute. So that is 23 plus 35.5, that is equal to 58.5 gram per mole. And Kb is given here, 0.52 Kelvin kilogram per mole. All right. And what else do you need? You need to find out first delta TB, because 4 things are given, 1, 2, 3, 4, only delta TB I don't know. So let us find delta TB is equal to 3.5 into 0.52 into 1000 divided by 96.5 into 58.5. Now somebody who has a calculator should do it. It is a little too much. So let us do it. 3.5 into 0.52. Somebody tell me the answer. Ashwin is not there again. No, Ashwin is there. Vaishnavi, Hari Raghav, who didn't come today? Hari Haran is not there today. Hari Raghav, you are generally very quick with calculations. Tell me. Sai Kalyan. Yeah, do it.
Ma'am, it's 0.32.
0.32. Yeah, 0.32. Okay, so 0.32 is the delta TB. Now, what is the question? We have to find the boiling point of seawater. Okay, so we know the difference. What is the boiling point of water if you want to find it in Kelvin? What is delta TB equal to? Delta TB is equal to T2 minus T1, right? T1 is the boiling point of pure water. So what is the boiling point of pure water? 100 degrees Celsius. So if you want to find in degrees Celsius, then you can write here T2 minus 100, right? So what is T2? T2 will be equal to 100.32 degrees Celsius. That is the answer. Did you understand the question?
Yes, ma'am.
Okay. Now let us see. Now this is another type. It is very, very easy. 0.1 molar aqueous solution boils at 373.052 Kelvin. Calculate the molar elevation constant. So what is given to us is M. M is equal to 0.1 molar. Okay, or what does 0.1 molar mean? It means moles per kilogram can be written as this. So M we know. And we know the temperature at which it boils. So we know T2. T2 is equal to 373.052 Kelvin. What do we have to find with this? We have to find Kb. What formula can we use now? Delta TB is equal to Kb into M. All right. Now we need to find delta TB first. We know only T2. What is T1 in Kelvin? T1. We have to find T1 also in Kelvin. Kelvin is the boiling point of pure water. So what is the boiling point of pure water? 100 degrees Celsius or 373 Kelvin. Now what will delta T be equal to? 373.T2 minus T1, right? So it is T2 minus T1. So what does it become equal to? 373.052 minus 373. That is equal to 0.052. So substitute the values. 0.052 into is equal to Kb into M. M is how much? 0.1. So Kb is equal to how much?
0.5.
So 0.052 upon 0.1, that is equal to 0.52. And what will be the unit? Kelvin, kilogram per mole. So sometimes in MCQs, you will find such simple questions. You should be able to do it. Okay, now we'll go to the next thing, and that is called depression of freezing point. Now, I don't know whether you have seen in some movies or somewhere when, there are countries where the temperature goes below 0 degrees Celsius. So if the temperature goes below 0 degrees Celsius, you must have heard there is a lot of snow. So the road is covered with snow. So when the road is covered with snow, it is very difficult to drive on those roads. So in those countries, what they do is they sprinkle salt on the roads. They sprinkle a lot of salt on the roads. What is the purpose of sprinkling salt on the road? When salt combines with water, the freezing point of water is lowered. That means the water now freezes below 0 degree, -4 degrees. It freezes at -4. So 0 to 4 degrees, the water will become liquid, will remain liquid from 0 to 4 degrees by adding salt. So if the temperature is between 0 to 4 degrees, then there will be no snow on the road because the snow will melt and it will go away. So the melting point will be lowered, or freezing point of water will be lowered by adding. So that is known as depression of freezing point. So sometimes, just like adding salt or any other solute decreases the vapor pressure and hence it increases the boiling point, the opposite happens for freezing point. By adding a solute, the vapor pressure is lowered, and when vapor pressure is lowered, the freezing point is also lowered. So that is known as depression of freezing point. So this is also another colligative property which depends only on the number of particles. Now, let me give you the formula here. Here it is called delta TF. Okay, depression in freezing point is equal to KF into M. It is just like the previous one. Only thing is, instead of KB, we use KF. What is KF? KF is known as cryoscopic constant. Cryoscopic constant. Okay, and here also all cryoscopic constant for each solvent is different, and the value of cryoscopic constant of that solvent will be given to you. Here also you can just easily expand it. You can write K is equal to KF into M. Instead of M, I can write it as the way I did, like that, WB into 1000 divided by WA into MB. So this is the equation number 3 for finding molar mass. You see, all these methods we use for finding molar mass of the solute. Mostly we use it to find the molar mass of the solute. Okay. Now you keep all these things in mind. We are building up towards real colligative properties. Right now, we are just doing the basic questions. In all these questions that we did till now, you might have noticed, except for in one question, all other questions, your solutes were such, you had everywhere it was written, a non-volatile solute which does not ionize or dissociate or associate in solution. So they are all, or generally we took urea, we took compounds which do not ionize. We will understand that reason later, but right now you see it is used to find the molar mass. So this value, how much elevation in boiling point you get, depends on, that will help me to decide the molar mass. Okay, so let us do a question here. Also the definition of cryoscopic constant is the same. Cryoscopic constant is equal to the depression in freezing point of a solution which has concentration 1 mole per kilogram. Okay, so let us do the questions for depression in freezing point. Now this is calculate the molality of the solution. So this starting with a simpler one. So delta TF is equal to KF into M. This time I have to find M, calculate the molality of the solution. Now first we have to find delta TF. Now the cane sugar freezes at 0.732, right? So here there is the T2, the temperature, let me show you clearly. So let the freezing point of pure solvent. V equal to T1, right? And freezing point of solution is equal to T2. Now, depression in freezing point, when you have to find out, remember the freezing point of solution in this case is less than the freezing point of the pure solvent, right? So you have to write it carefully. So in this case, it is an aqueous solution. So what is the freezing point? Freezing point of water is equal to what? 370, no, it is 0 degrees, sorry, not 100 degrees. Freezing point of water is equal to 0 degrees Celsius, which is equal to 273 Kelvin. All right, 273 Kelvin. Now, how much it has, now sugar is freezing at 0.372. So what is the difference? So 0.372 is the difference. So because here it is given in degrees Celsius. So if you take degrees Celsius, so the difference is 0.372, right? Is equal to Kf is what? 1.86 into M. So what is M? M is equal to 0.372 divided by 1.86. Molality of the solution.
And 0.2.
How much?
0.2.
So it is 0.2 molar or 0.2 moles per kilogram. Okay. These questions, they come in MCQs only. So you will be having answers and you have to select the correct answer. This time today, yesterday I had written some choices. This time today I didn't get time to write. Now do this question. 45 grams of ethylene glycol is mixed with, yes, somebody saying something. Sai, Kalyan, you want to?
Miss, one second. I will just take a screenshot.
Yeah, complete it.
Took me a second, move to the next slide.
Yeah. Shall I now? Shall I move to the next slide, Sai Kalyan?
Yes, ma'am.
Okay. Now look at the next question. Now you have to find the freezing point depression and the freezing point of the solution. So 45 grams of ethylene glycol is mixed with 600 grams of water. Okay, Kf is also given to you. Now you have to only find ethylene glycol, the formula is given. So you have to calculate MB. We don't know, MB is not given. So let us calculate MB. MB is, you have to calculate MB, what you have to do? 2 into 12 plus 1 into 6 plus 2 into 16. I hope you understood why I am doing this. Here, I have taken this. So 2 atoms of carbon into 12, then 1 into 6 of hydrogen and 2 into 16 of oxygen. Okay, so what will I get? 32. This is 24 plus 6 plus 32. So that is equal to 62. So now let us put the values. WB is equal to 45, WA is equal to 600 grams, and MB is equal to 62 gram per mole, and KF is equal to 1.86. So the moment you find 4 things, you can immediately start substituting. So delta TB is what we, not TB, delta TF is equal to how much? 45 into 1.86 into 1000 divided by 62 into 600. So what is the value that you will get?
Ma'am, then TF will be 2.25.
Yeah, 2.25. Delta TF is equal to 2.25. Correct. So this is the depression in freezing point. Okay, so this is the depression. So what is the freezing point of the solution? It is in degrees Celsius. If you want to write, then it is 100. No, not 100, 0.
Ma'am, it will also be 2.25.
Freezing point of the solution will be less than 0, no? It cannot be 2.25.
Oh, okay.
It will be less than 0. So 0, it will be minus 2.25, isn't it? Below 0, minus 2.25. 0 minus 2.25. Or it is better to write it in this one. So 273 minus 2.25. Right? So it is 5, this is 7, this is 1. So it will be 270, it will be equal to 271.75. If you don't want to write in minus, otherwise it will be minus 2.25. So boiling point T2 of the freezing of the solution, freezing point of the solution will be 271.75. Here I should not write T2, T1, it becomes confusing. It is freezing point of solution. Got it, all of you? Yeah, tell me.
Ma'am, near the freezing point depression is 2.25 and T1 is 273. So shouldn't we add those two to get T2?
What difference in freezing point? See, when you add it, when you are there is elevation, no? Here it is becoming less than 0. So what is the freezing point of pure water? 273 Kelvin.
Yes,
right?
This is T1, no, this is T1.
What is it?
T1, miss.
This, if you consider this as T1, then change in freezing point should be T1. It should be change in freezing point should be here. That is why I said don't take T1. Difference in freezing point is when we did elevation in boiling point, we did T2 minus T1, right? Why? Because T2 was greater than T1. Here I will have to do T1 minus T2 because T2 is less than T1.
Okay, ma'am.
So delta TB here, delta TF is equal to T1 minus T2. If T1 is pure and this one is of solution. Now do the next question. This one I will not give you any help. Now you all do it yourself. Or just copy down the question. Don't now I want to finish something more before the end of the class. I have only 25 more minutes. So if you have understood, just go through this and see whether you can answer it. It is the same type. So just copy the question, take a screenshot and keep it, and then you can solve it later. All right? All of you, please note down the question. Shall I go to the next thing? All of you have noted? So I have many more questions on freezing point, but I will leave it for the time being. I will send it in the worksheet for you, all of you. I hope all of you understood how to do these questions. Okay, so now we will go to the next topic so that I can finish this part, because then we can I can send you some worksheet for all this. So today, now the last thing that we are going to do for today, that is osmosis. Okay, now what is osmosis? Do you understand? Any one of you? Now supposing I take a container and in that I put water, right? And in the water I put some raisins. Do you know what raisins is? Does any one of you understand what raisins is?
Yes.
Tell me, what do you call raisins in Tamil?
And Draksha.
Drakshi. Drakshi, yes, because Drakshi, I know it is the word for also grapes. So these are dried grapes, right? So they are called raisins. Now I put some raisins in water for some time, right? What will happen? Can you tell me after some time?
When it gets swallowed.
Yeah. Boys, tell me, somebody. What will happen?
Miss,
Has anyone?
The raisins became like puffed up.
Yes, the raisins will become swollen. They will swell up, right? So the raisins were like this, and after some time, the raisins will swell up like this, isn't it? They will swell up. Now, why do they swell up? Do you know? Anybody? Why do they swell up? Because obviously they are absorbing water, isn't it? Water is being absorbed and water is moving into the raisin like this, right? Water is moving into the raisin, and because of that, the raisin swells up. Okay. Now why does raisin absorb water? Okay. Raisin absorbs water because the concentration, there is a difference in the concentration of water inside and outside. So outside, it's a very dilute solution. Inside the raisin, it is a very concentrated solution. So from the dilute solution or from the region of low concentration, the solvent moves into the region of its high concentration. So what happens? Water moves from outside towards inside. Okay. This process happens only because there is a layer outside the resin. You know, the skin of the resin is semi-permeable. Semi-permeable. If any one of you has learned biology in 10th standard, you will understand what I'm talking about. Now, semi-permeable membranes. These are special membranes which, what is speciality about semi-permeable membranes? They allow only solute particles to move, not solute, sorry. So, they allow only solvent particles to move through it. They allow only solvent particles to move through it. Right? So, because there is a difference in concentration, the solvent, which is water, moves into the resin. It absorbs water because there's a difference in concentration. Now, this movement of water from dilute to concentrated solution, this is known as osmosis, especially when they are separated by a semi-permeable membrane. Semi-permeable membrane is which one? It is the lining of outer covering or the skin of the resin. So skin of the resin is a semi-permeable membrane. So when two solutions, they are separated by a semi-permeable membrane, then what happens? The solvent particles, they move from the region of high concentration, from the region of their, you know, from dilute solution towards the concentrated solution. Now, supposing I do the reverse, you must have seen, all of you must have seen jams. You must have seen jam, or you must have seen this, you know, what you eat. What do you call it in Tamil? I don't know. Achar. Do you understand achar? Achar is a Hindi word. Pickles. You know pickle? Right? So achar jams are very sweet. That means they contain high percentage of sugar, high percentage of sugar. And pickles, they contain high percentage of salt. Why do you put lot of salt in pickles? And why do you put lot of sugar in jam? Why? Because when I put lot of salt in the pickle, what happens? If there is a bacteria, which, you know, if I make a pickle, it doesn't go bad for a long time. Why? Because all the bacteria, they are not able to survive, because the solution inside, you know, the bacteria has, this is a bacteria, it has some solution inside, but the pickle outside has a more concentrated solution. So what will happen? The water from inside will move outside now. Then what will happen? There will be no water, it will shrink and the bacteria will die. So bacteria will not survive if the concentration of sugar or the salt is very high. So this process here, where the water is moving outside the cell, it is called exosmosis. So those who know a little bit of biology, they will understand there are two things which happen, either an endosmosis or exosmosis. You see it lot of it happening in the cells. The plants, how do they absorb water from the soil? They absorb the water from the soil also through endosmosis. So slowly one cell to the other cell, the water moves only through this process known as osmosis. So what is osmosis actually? Osmosis is that when two solutions of different concentrations. So now I will show you. So I have a container here and I have this separated, there is a semi-permeable membrane here, semi-permeable membrane, right? And here I have pure water. And here I have a solution in which I have solute particles. Right? So what happens is that the water from this region, water from the region where it is dilute, this may have less solute particles, the other may have more. I haven't shown any solute on the left. This is pure water and this is a solution. Right? So water will start moving from here to here. All right? So supposing, so slowly the water will move from here to here because the semi-permeable membrane does not allow the movement of solute particles. Just let me put some solute here also. So there is some solute here, right? And there is some solute on the other side. So this is a dilute solution. This is a more concentrated solution. So the solute solvent particles, they will move from the region of its low concentration towards the higher concentration. And so this movement will continue till both the solutions have same concentration. The solute particles will not be able to move. Only the solvent particles will move, and this process we call it osmosis. Now, when osmosis is happening, then supposing when osmosis starts, I put a pressure. Now, this is the solvent particles are moving in this direction. Supposing I apply a pressure in the opposite direction. I apply a pressure in the opposite direction to prevent the movement of these solvent particles into this side of the compartment. That pressure is known as osmotic pressure. So osmotic pressure is which pressure? Which prevents osmosis. And what does osmotic pressure depend on? It will depend on the concentration of the solution here. So what is osmotic pressure? Osmotic pressure is a pressure that you apply on the membrane, semi-permeable membrane, to prevent the movement of solvent particles from a dilute solution towards the more concentrated solution. So from where will you apply the pressure? From the side of the concentrated solution. So from the concentrated solution, if I apply pressure, then the osmotic pressure, then the solvent will not be able to move. Now, if I apply a pressure more than osmotic pressure, more pressure if I apply, then what will happen? The solvent particles will now start moving from a concentrated solution towards a dilute solution, right? That is called reverse osmosis. Okay, reverse osmosis. Where do you use reverse osmosis? Can anyone tell me? Anyone has heard of reverse osmosis?
The concentration of water is more.
Yeah, RO. Yeah, you have heard of RO. RO for purification of water. So purification of water we do by using reverse osmosis. So what happens? You take salt water. So in Chennai you have a lot of sea water. So you can. There is a lot of water. If you take underground water also, it contains a lot of dissolved impurities. Dissolved impurities cannot be removed by filtration. So in such cases, what do? We use reverse osmosis. So what do? We apply pressure more than osmotic pressure. So what will happen? Solute particles will not move across the semi-permeable membrane. Only the pure solvent will move. So what collects on the left side now, this will be pure water. All right. So that is what we do for reverse osmosis. But now what are we doing learning this for osmosis? Is for finding the osmotic pressure. If I know the osmotic pressure, I can find the concentration of this solution because osmotic pressure is related to the concentration of the solution. So higher the concentration, higher will be my osmotic pressure. So using that, I can find out what is the solute present in my solution. So that is what we are going to do. But before I give you the formula, please understand that of two solutions, one which is dilute, it is known as hypotonic. Hypotonic. Right? That is the dilute of the two solutions, because whenever we are doing osmosis, we are comparing two solutions, one which is dilute with the one which is concentrated. The concentrated solution is known as hypertonic. Okay, so always the movement of solvent particles is from hypotonic towards hypertonic. And this will continue till both the solutions will have same concentration. So in terms of osmosis, when two solutions separated by a semi-permeable membrane have same concentration, then we call it isotonic. Isotonic solutions are solutions which have same concentration or same osmotic pressure. Hypertonic solution is the one which has a higher osmotic pressure, and hypotonic one is the one which has a lower osmotic pressure when you are comparing the two solutions. Okay, now let me give you the formula here. The formula here is, it is similar to the formula that you use for finding pressure. So you have learned this pi PV is equal to nRT, that is the gas equation. The same formula we use. So we take, instead of pressure, we write pi. Pi represents osmotic pressure, is equal to nRT by V. So what is pi? Pi is osmotic pressure. And N is equal to number of moles of solute. Why did we do this? Because I told you it's directly proportional to the concentration. And R is the gas constant. In these calculations, the gas constant that we use is 0.0821 liter atmosphere per mole. And T is always temperature in Kelvin. And V is volume in liters. Okay. So keeping all this in mind, we can find out the osmotic pressure. Okay, we can simplify this equation also. We can write pi is equal to number of moles by volume of solution. In liters is also known as concentration of the solution. So we can write concentration, CRT. This is also sometimes we use. C is equal to concentration in moles per liter. We can also write this formula as number of moles. We can write it as WB into R into T divided by MB into V, volume in liters, remember. Always volume is in liters. So let us do this, use this formula for, so this is the formula number 4 that we are learning. Okay, this is the formula number 4. So we have learned 4 different formula. This is the 4th one. Now, this is the question.
Can you go to the previous page?
Previous slide.
Yes, ma'am.
So this is at 25 degrees Celsius, typing error. Yeah. So at 25 degrees Celsius, 3.5 grams of albumin in 100 ml of water produces osmotic pressure of 0.041 atmosphere. What is the molecular mass of the albumin? Now here, remember, your pressure should always be in atmosphere. If it is not in atmosphere, you will have to convert it into atmosphere. So pressure can be in terms of atmosphere, it can be given in form of bar, it can be given in form of millimeter of mercury, or in form of Pascal. So all conversions you should know, okay? So let us do this one. Is straightforward. So pi is equal to, this is weight also is given. So it is equal to WB into R into T divided by MV into volume in liters, right? So pi is given here. Pi is 0.0414 is equal to WB is 3.5 into RT. I told you 0.0821 into temperature in Kelvin. So 273 plus 25. So it is 298 divided by MV, which we have to find out, and volume in liters. So 100 ml by 1000. So that is 0.1 liter. So 0.1, right? 298 Kelvin. So MB will be equal to what? 3.5 into 0.0821 into 298 divided by 0.40414 into 0.1. Don't be afraid of the answer. It is going to be very large. Because albumin, it means it has its molecular mass will be very, very high. So the answer that I get is 20683.6. Gram per mole. Ashwin, are you there? Ashwin?
Ma'am.
Yeah. So Ashwin, if you are you able to do it?
Yes, ma'am.
Good. Shall I go to the next slide? Okay, just do one more question. Note down this question and then we can stop. So we have learned 4 colligative properties and we have learned how to find molecular mass of a solute or some value, the 4 formulae that we have learned. First one, P0 minus PS upon P0 is equal to WB into MA divided by MB into WA. That is first one. The second one that we have learned is delta TB is equal to KB into WB into 1000 divided by MB into WA. And the third one we learned was for depression of freezing point. It is KF into WB into 1000 divided by MB into WA, right? So this is 2 and this is 3. And the fourth one is pi is equal to WB into R into T divided by MB into volume, that is in liters. Okay, here you should remember WA is in grams, WA is in grams. So we did different types of questions and formulae. Now after tomorrow's test, anyway, you'll be busy for preparing, but by Monday, we will send you a worksheet with lot of such questions you should try and solve. I think the numericals are very simple here. So direct ones I will not send. I will send where you will have to think and apply yourself a little. Okay. So one by one, tell me, Sai Kalyan, before going, please switch on your camera, Sai Kalyan. I want to see. Yes, so Sai Kalyan, have you understood this much of solutions? Please unmute.
Yes, ma'am, I understood.
Okay, okay, then see you. Bye. Vaishnavi, have you understood? Please switch on your camera, Vaishnavi.
Yes, ma'am.
Yes. Ashwin, what about you? Have you understood? Please switch on your camera and tell me.
Yes, ma'am.
Yeah. So you have completed everything. You have noted down all the formulae you understood.
Yes,
Then
ma'am.
who else is there? All others have already left. So shall I stop sharing? Vaishnavi, have you completed?
Yes, ma'am.
Yeah. Okay then. See you all.
Ma'am,
Bye.
Thank you, ma'am.
for the last
Yeah.
question
Sai
you gave?
Kalyan, what is it?
Can I know the answer for the last question you gave?
Okay, I will. Which is the last question where I am
Was glucose?
glucose thing. What is the answer that you are getting?
I got 18.46.
Yeah, I think it is right. I think it is right. Okay. So, okay, very good. Well done. Bye.
Bye.